Hello everyone. Today we are going to solve the problem first set bit. So it is a difficulty basic question. So given a number n having only 1 and all the other numbers are zeros in its binary representation. So find the position of the only set bit. If there are 0 or more than one set bit, the answer should be -1. The position of set bit should be counted starting with 1 from the LSP side in the binary representation of the number. So if you see means indirectly in the integers, the numbers with only one set bit in their binary representation are actually the powers of 2, like 2 power 1, 2 power 0, 2 power 2, 2 power 4, 3, 2 power 4, 2 power 5, like that. So 0, 2, 4, 8, so on up to 32 and etc. So like that. These are the only numbers which has only one set bit in their binary representation. So they are saying that if the given number is a power of 2, then return the position of the set bit which is only 1. But if the number is 0 or it is other than the power of 2 number, then simply return -1. So if you see the example, the first one is a 2, which is a power of 2, we know 2 power 1. So the representation has 1 0 in binary. So there is a set bit only 1 and its position is from the LSP 1, 2, 2. So 0 is 1 and 1 is 2. So the set bit position is 2 starting from the LSB. So like that. So you can say the expected complexity is log n and the space is 1. So how to solve this program? So first one, we will write some base cases like if n is 0 or n is not power of 2 number, then return -1. They already said that. So if the base case is not satisfied, then it definitely a power of 2 number. Declare a variable position POS. So use loop until the number does not become 0. So we use a loop until the number does not become 0. So in the loop we right shift the number by 1 and increase POS by 1. So there is only one set bit. So if the set bit is vanished due to the right shift at any time, then obviously the number will be going to all zeros. So the value will be 0. So if the value is still not 0, then there is a set bit still somewhere, the only set bit. So we will use this right shift logic. And at last the POS is the position of set bit in the number binary representation. That's it. This is how we are going to solve. So we will try run using a test case. So now we said we write the base case which is n equal to 0, or how to find the power of 2 number. There is a small and effective logic which is n and it is not star. If n and n minus 1 is not equal to 0, then it is not a power of 2 number. So like that, n and n minus 1 AND operation output is if not equal to 0, then it is not a power of 2 number, and if now n is not equal to 0, then they said in this both cases we need to return the minus 1. Okay, completed. So step 2 is POS. The position they said to start from the 1, 2, 3, 4 from the LSB like that. So while our number is greater than 0, we right shift it by n is equals to n right shift by 1, position will be increased. At last return the position. We need to use some brackets here. If n is equal to 0 or n and n minus 1 is not equal to 0, then return minus 1. So it is just a matter of brackets. So we need to correct the bracket here. So we can see the hidden test cases are passed. So first we will dry run using an example. So example is 2. So first, what is the binary representation of 2? It is 1, 0. So now if we check with the base case, so is n is equals to 0, 2 is not equal to 0, and n is 1, and what is the n minus 1? It is 1. So 0, 1. So which is equal to, AND operation means both bits equal to means 1, otherwise 0. So 1 and 0 not equal, 0 and 1 not equal. So the output will be 0, 0, which is 0. So we wrote here, if the output is not equal to 0, then return minus 1. Or if the n is equal to 0, then return minus 1. So both cases are failed here. So the base case is passed. Means step 1, the base case was not affected to it. So now POS will be 0, and while our n is greater than 0, now n is 2, and so we go inside the loop, which is like this. The first iteration will be right shift by 1. So 1, 0, after right shifting by 1, it converts to 0, 1. So the position now will be 1. Now again another iteration. Now 0, 1, and its minus 1 means 0. Again AND operation will give us 0, 0, and POS is equals to 2. Now if you see, here we need to see the position is 2, and in the third iteration, when n is already 0, then it's terminated. So third step is output is POS equal to 2. So this is the output, we can see it is 2. So it is matching here. So this is how the code is working. You can see the example here. This is the approach or the pseudocode or the steps for algorithm of this code. So now we are analyzing the time and space complexities. So it takes big of 1 space, this loop takes log of n, because we all know the maximum possible number of bits in any integer variable binary representation are 32-bit representation. So we are running our loop on the number of bits only. So our loop will maximum run the number of times will be 32 only. So maximum number of times our loop may run will be 32 at max. So we should see it as a big of one time only, but okay, it is depending on the input size. So let us take it as big of log n. So if you compare, the n value may increasing sequentially, but the number of bits will approximately increase with the log n of length. So it is log n. So these are the declared normal before only values. So finally, time is, we have only one depending time, which is log n. So spaces, all the big of 1 command will also have big of 1. So expected and our code are matching. So this is how we need to solve this program the most efficient way. Kindly go and practice this problem. The program link is given in the description. Thank you for watching. Please subscribe to our channel.